I'm Richard Coulter, Head of Marketing for Fujitsu's network business, and I'm here with Kai Mao, Head of Business Strategy for AI-RAN. AI-RAN has the potential to be a disruptive force in the industry, so Kai's here to share some of his experience and knowledge on this topic. Thanks for your time today, Kai.
Thanks, Rich.
AI has been a growing focus for the telecom industry. We've heard about how AI in general can make network operation more efficient, but the concept of AI-RAN is fairly new. Tell me what AI-RAN is and what the drivers are for it.
So AI-RAN basically is the concept of utilizing the shared infrastructure for both RAN and AI. RAN being the baseband processing, which is the CUDU part of the RAN on a common infrastructure. Traditionally, RAN is based on dedicated hardware requiring specialized hardware, and then more recently has become virtualized on common servers, but still requiring a component of hardware acceleration or dedicated for the RAN processing. AI-RAN now moves that functionality for acceleration into a GPU. So now you're using a common platform of compute and acceleration and packet processing that all other workloads use today. So it's the same concept that cloud uses.
Yeah, that's really interesting because I know virtualization's been a long journey we've been on. So tell us more now what it is, but why is this important?
So the significance of this is that if you look at 5G, it's really been about retention. You increase the speed and you have incremental revenue. The original promise of 5G, where there was supposed to be new markets and new revenue streams coming in, it really didn't get realized. But then on the other hand, right now you're seeing this growth of AI, right? AI has become the next inflection in the social world and great impact. So AI-RAN takes advantage of this to leverage the growth in AI for the RAN network.
Yeah, that's really interesting. I know even you and I were talking about how those new use cases that 5G was promising were going to be great and help in so many ways for enterprises, and we just haven't seen that yet. So how is AI-RAN going to help that? Can you tell me more about some of the values that AI-RAN is going to bring to the network?
So Fujitsu is part of the AI-RAN Alliance. The AI-RAN Alliance has defined the categories, to make it simpler in terms of AI and RAN, AI for RAN, and AI on RAN. And really, these are geared towards improving the operations, simplifying the operations, improving the performance of the network, as well as creating new revenue streams and opportunities.
Yeah, that's interesting. So do we want to go through these kind of one at a time and talk about what their benefits are? So maybe Let's start with AI and RAN.
Sure. So AI and RAN is the fundamental idea of sharing the same infrastructure for AI and RAN. By virtualizing or softwareization of the baseband software onto a common platform, you realize the same benefits that cloud has. So this is in terms of the agility, the scalability, the availability that you have, as well as the large economies of scale that the cloud environments provide. And also because now your solution is purely software-based, you get the advantage of real automation capabilities.
And Kai, can you tell us, are there any other benefits for a shared resource model?
Sure. So one of the unique results of having a common platform for both AI and RAN is the fact that now you can share and pool the resources across both workloads. So if you look at the typical usage pattern of a RAN workload during busy hours and off hours, it's quite variable, right? And you have a lot of wasted capacity during the day. And also, because of the stringency of the requirements, you have redundant capacity, and that redundant capacity pretty much sits idle. But now that since you're using the same infrastructure, you can utilize that idle capacity and that redundant capacity for other applications, such as AI applications, and monetize that. We've actually seen that with a very high level study that you get a less than 2-year return on investment just by monetizing the unused wasted capacity that you have today.
Yeah, that's really good benefit and starts to get the monetization of the network that was really intended from the beginning. So that's great. So let's jump then to AI for RAN and talk a little bit about that part of AI-RAN.
Sure. So AI for RAN is the utilization of AI and GPU acceleration in the implementation of the RAN itself. So one of the aspects of that is incorporating AI algorithms and GPU acceleration for the actual data plane implementation. So examples of this are signal processing or schedule offloading. And this has the potential to actually increase your bits per hertz, right? And everybody knows that the most valuable asset the operators have is their spectrum. It's very expensive and they have a lot of requirements around those. If they can maximize the capacity that can be generated for that, it's very beneficial to them. Second aspect of AI for RAN is utilization of AI at a network level. So AI adds context awareness and intelligence and historical information and predictive capabilities. And this can be used to enhance existing optimization systems, as well as adding new capabilities into the network. So for example, 3GPP is looking at adding distributed MIMO as a way to improve the overall network performance on the uplink, which is a great benefit because that's something that's been struggling for a long time.
Yeah, so it's really taking AI, applying it to the network to improve efficiency and get more out of it. So a more traditional use, but a really important one nevertheless. So the last one's AI on RAN. So let's jump to that one.
So AI on RAN is the one that's really exciting. AI on RAN is the future. If you can imagine a world where you actually will have an AI RAN network, AI RAN deployments are widespread, the types of innovation that could occur. So you would have new AI services that are network aware, incorporated and integrated with the network so that you can have applications that take advantage and make requests in terms of latency requirements, mobility requirements, or even location requirements, and be able to generate new classes and new markets based on those applications.
Wow, yeah, that's three really important aspects that are going to add a lot of value to the mobile network in general. Jumping back to shared resources, if MNOs share the resources between AI and RAN, how do they ensure that there are enough compute resources for the RAN?
Yeah, that's a very common question. It's a very good question. RAN is a priority workload, right? And the good thing about this is that cloud and the AI market have already solved this. This is something that's done already in terms of managing workloads. It all comes down to proper dimensioning and implementation of your data center resources or your compute resources. And it also has a little bit of effect in terms of which direction you're coming from. Are you building a RAN network and then adding AI, or are you building an AI network and then adding RAN, right? And then you would kind of plan your network differently depending on those two. But at its core, you always want to make sure you have enough capacity in your system to be able to account for the reliability that you want to meet and the capacity you want to meet for your RAN, and then utilizing and dimensioning any additional for AI. So it also depends on the classes of service that you might offer, and there's ways to offer those services without infringing on the RAN. So for example, there's GPU as a service. GPU as a service is reselling the unused capacity for AI workloads. And the primary driver for that today is training of large language models. As you know, everything is driven by these models. And those training can be done over a course of time, and they're interruptible. So providing the unused capacity as what's called spot instances. Spot instances are interruptible service so that you can prioritize your RAN capacity if that capacity needs to be taken back, providing that for the large language model training. Then there's also AI as a service, which is a token-based service where you use the excess capacity for inferencing, real-time inferencing. And token requests are very small units of AI requests. The inference request comes in very quickly, and it can be farmed to the available GPU pool that's available at that given time. So it doesn't occupy the resource for a very long time. It's just when it's necessary, it's utilized. And then the last one is the more traditional one, where you actually have a new AI service that's running on top of the infrastructure. In that case, you'd have to actually dimension for the demand of the AI service, and then account for that in the overall pool that you would require.
Yeah, so it's really just about the planning of the network and making sure you're taking into account all the loads and meeting it. And this seems to be something that telecommunications companies, mobile network operators have done for a really long time. So it's just doing it with a different level of service.
That's right. They've been doing it with network. Now they need to do it with the compute as well.
Let's jump back a little bit and look at kind of different parts of RAN and what's the linkage between them. So AI RAN, Open RAN, and virtualization, and how all these things come together.
So something that Fujitsu is a very strong proponent of is openness, right? We released our first open radio back in LTE as the first commercial deployment, and we've always supported openness. And it's our belief that openness will enable the AI RAN ecosystem, and we plan to leverage that with our work with AI RAN Alliance and with our partners to ensure that we create an open architecture that can enable other players in the AI RAN space. Additionally, something that's interesting is that AI can also help openness. So in an open environment, you can think about it as a multi-vendor. Multi-vendor adds a level of complexity in terms of managing configuration operations. AI can add an intelligence to help address that. Right? AI is very good at translations. It can learn the various languages of each of the different vendors and the nuances of behavior of those, and provide a translation type of service or to be able to help the user have a more simplified intention-based interface that the AI system then disseminates to the various vendors' equipment. And also because each vendor's equipment behaves slightly differently and its adherence to the standards are a little bit different, the AI systems can actually take that into consideration when optimizing the network.
Yeah, interesting. So let's talk now kind of from general to kind of what you and we at Fujitsu are actually doing around AI RAN.
So Fujitsu has been a pioneer in AI RAN for a very long time. We've been working with our partner NVIDIA for over 4 years, enabling our solution on their GPUs. We were actually the first company to demonstrate our commercial RAN system running on a GPU with an AI application over 2 years ago. We've also been working with NVIDIA, integrating our service management orchestration system with their network virtualization function system to coordinate both the GPU and AI workloads over a common GPU pool. We're actually going to be demonstrating that at Mobile World Congress this year as well. In addition, we've been working with SoftBank in our collaboration for the first AI RAN deployment in 2026. And we are looking at building a full RAN ecosystem where it's not just about the baseband on GPU, but also our smart front haul to be able to carry both the front haul traffic and the AI traffic on the same network, as well as our open radios to support our open ecosystem, and also working with our partners to in terms of the infrastructure, the GPU side, and also the AI side to be able to create a broader solution overall. And we even have to assist the operators in terms of deployments, because AI RAN is such a new thing. We have a series of targeted AI RAN enablement services for CO deployments and such to help with the actual deployment.
Yeah, that's really seems like a pretty broad offering from services to transport all the way through the RAN. So really interesting kind of what's going on in the market and what Fujitsu is bringing to it. So kind of moving on to AI RAN. We've talked about AI RAN. Like, what excites you the most about the potential it can bring to the network?
So for me, AI RAN represents the new innovation that can occur. Right? We have a lot of AI innovation now, but you can imagine what could be birthed if you had AI RAN deployments out in the marketplace, right? So AI RAN at the edge, AI RAN with mobility, the types of innovation that will be available for the application developers that will come about. I'm very excited to see what the future will hold in that. Additionally, AI RAN, in my opinion, will become commonplace. All networks will have some flavor of AI RAN, and it will drive the future competitiveness of networks. So really, the level of competitiveness that an operator will have will be dependent on how much of AI RAN they deploy, how much they adopt. And that will realize itself in terms of the benefits of the operations, the performance enhancements, or the new revenue possibilities that they can get. And the operators are actually the best positioned to be able to deploy AI RAN systems because of their network capacity and their real estate that they have and their incumbent subscriber base that they have that they can leverage for the deployments.
Yeah, that's really exciting. I really appreciate your time today, Kai. This is a really important trend, as Kai mentioned, talking about monetization, inefficiencies in the network. So really interesting to see where this comes, and really, again, appreciate your time coming to talk to us about it today.
Thanks, Rich.